Hi, Miss Hogan here. I'm going to give a quick video tutorial on how to solve exponential and logarithmic equations if you have a single exponential expression or a single logarithmic expression. So these are your basic type, but it is a quick way and hopefully you'll find it helpful. So before we get started, the first thing we need to make sure that you've already learned is how to convert between the two forms. That's important to do Ms. Hogan's method. So if you had an exponential expression like b raised to x equals y, I need to make sure that you could rewrite that as a log. So as a logarithm, we use log, and then we need a base. Now key is the base of your exponential is the base of your logarithm. So that number is going to stay the same. And then the y that was over here now goes with the b, and that's equal to the x that was up here. Some people even do like a circular pattern. So log b goes to y, back to x. Make sure you can convert the two forms before you start doing my methods. Let's start out with some exponential examples. I've got two here for us to look at. Both of them have a single exponential expression equal to a number. The first one, 2 raised to x equals 33. Some other ways that you might do this are looking for same bases on both sides, maybe taking the logarithm of both sides. But what I've found to be sufficient is just to rewrite this in its logarithmic form. So let's do that. What is the base? Well, the base of this exponential is 2, so the base of my logarithm needs to be 2. Going around, I'm going to do log base 2 of 33. And that would be equal to the x that's up high. Now the reason I think it's neat to go ahead and rewrite it like this is you can now use your calculator to calculate log base 2 of 33. Using change of base, you can use either the common log, log, or the natural log, ln. Base goes on bottom, big number goes on top. So in your calculator, you'll type log of 33 divided by log of 2. And when you do that, that solves this equation. Most of the time you will get a decimal, so be careful and look for what your problem asks you to round your answer to. We're going to round to 3 decimal places. So grab your calculator, type this in, and make sure you get a result that x is approximately 5.044. And that's the log of 33 divided by the log of 2. Or what exponent you can raise 2 to get 33. First example. Let's look at example 2. It has a little bit more to it. This one, though, you can still solve the same way. Let's convert it to its logarithmic form. So here it would be log base 4 going around. Now we have 7 equals the exponent, which is this entire 3x minus 5 term. So what happens here is you still can use your calculator, but you're going to have a little bit more work before you're done. So in your calculator, you could go ahead and get ready by using your change of base. With the common log, it would be log base on bottom, 4, 7 on top. And that's equal to 3x minus 5. My advice is to do this, but leave it in your calculator and do the next steps so that you don't round until the very end. So what are the next steps? Well, you'd have to add 5 to move that 5 from this side over here. So that would give us log of 7 over log of 4, whatever you get there, so I'm going to keep it in parentheses, then add 5, and that's equal to 3x. Last step, divide by 3. So I'd have to divide this by 3 and divide that whole thing by 3. And that would give me what my x is approximately. So to 3 decimal places, check your work with mine. Remember, do this first, then add 5. Then divide by 3. And if you follow those steps, you should get 2.135, rounded to 3 decimal places. So what did we do here? If you start with a single logarithmic expression, you can solve these equations by converting them to their, I said logarithmic expressions. I'm sorry. If you start with a single exponential expression, it becomes a single logarithmic expression when we convert. So we're going to solve exponential equations by converting to logarithmic. Here's a question for what's next. If you start with a single logarithmic equation, can you convert it to exponential? You got it. So we're just going to use this in reverse. And we're going to do the same method, but in the opposite form. Let me show you one example of that before we're done. So this one's going to look a little different because we're starting with a logarithm this time, but it's still going to be solved using a similar approach. So here's my example number 3. Log base 2, in parentheses, we've got 10 plus 3x, and that's equal to 5. So this equation has a single logarithmic expression. And because it has a single, we can use this rewriting form to get it into exponential and solve it that way. The way you do that is you keep your base, go to the other side as your exponent, and what was inside now becomes what it's equal to. Our base over here is 2. Raised to the other side, 5 is my exponent, and now it's equal to 10 plus 3x. I rewrote it in its exponential form. And the good news is now I can solve it because 2 to the 5th is a number I can calculate. 2 times 2 times 2 times 2 times 2, or 2 to the 5th in your calculator is 32. Now we've got a linear equation. So I'm just going to use my solving skills to come up with an x value. Minus 10, to move that over, leaves 22, equals 3x. Finish by dividing by 3. Now, your problem may want you to leave this as 22 over 3. It may want you to go ahead and give the decimal form. So just be careful with what problem that you're working. The decimal form here would be 7.333, rounded to 3 decimal places. So in summary, if you're solving exponential or logarithmic equations that have a single exponential or logarithmic expression, look at what you start with. If you start with exponential, try to write it as a log. And if you start with a log, write it as an exponential. And that's how you're going to solve. I hope that helps.